Hi class. This lesson focuses on using the quadratic formula to solve quadratic equations. In this document at the top, we have the derivation of the formula itself using the method of completion of the squares. It's kind of interesting and you can look through it if you like, though you won't be tested on it. Here's what we need to use. The quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. The important quantity in the quadratic formula is the discriminant. And that's the value of b squared minus 4ac here under the square root sign. There will be 3 cases for our x value answers, and they are all dependent on the value of that discriminant. If that value is positive, we can expect 2 real roots. They will be unique. If the discriminant is exactly 0, we will just have 1 real number answer. And with a negative discriminant, we would expect complex roots. And we've spent a good deal of this course already focusing on complex numbers. So in this particular module, when we do have a negative discriminant, we'll simply state that we have no real roots. Okay, so time to look at an example. We'll start with example 1 here at the top of the page. We have 9x squared plus 24x plus 16 is 0. This means our values for a, b, and c are 9, 24, and 16 respectively. I've written the quadratic formula here, and now we begin substituting into it. Negative b will be negative 24. Here is our b squared minus 4ac under the root sign, and in the denominator, 2 times the value of a, which is 9. So our denominator will be 18, 2 times 9. At this point, we calculate our discriminant. So you should be able to enter this directly into your calculator in one step. 24 squared minus 4 times 9 times 16. You will get 0. Which means we have the second case, the case of 1 real root. Its value is negative 24 over 18. And this reduces to negative 4/3. Example 2 here is a good reminder that we must have perfect quadratic form before we start, which means we want the form ax squared plus bx plus c is equal to 0. So that means bringing these 2 terms over to the left side. You can see that in doing so, they are subtracted since they were positive quantities on the right. This now gives us the following values. A is 2, B is negative 4, C is negative 3. Now when you substitute into the quadratic formula, it's a little bit tricky if the B value is negative. The negative of negative 4, of course, will be positive 4 out front here. And the other trick is inside here, make sure that you put a bracket around negative 4 in order to square it, because that is the only way your calculator will give you positive 16 here as required. Okay, so we get positive 16 minus 4 times 2 times negative 3. This gives us 40 as the discriminant. This number being positive ensures that we have the case of 2 real and unequal roots, and they are found by using 4 plus root 40 in the numerator here and 4 minus root 40 in the numerator here. Work out the numerator first in each case, then push equals and divide by 4. And you should get these two numbers. I have rounded these to 3 significant digits. Okay, here is example 3. 1.5x squared minus 7.5 is x times. Here in the bracket, we have 2.2x minus 3. Again, we're looking for a perfect quadratic form. So first, we're going to open this bracket up carefully. We are then going to bring these two terms to the other side of the equation. We will be subtracting 2.2x squared and adding 3x. Collecting like terms means that the coefficient of x squared will be negative 0.7. That's 1.5 minus 2.2 is negative 0.7. Okay, the coefficient of x will be positive 3. The constant will remain negative 7.5. So from that, we get our values for A, B, and C. Substitution into the formula now. Negative of b plus or minus the square root of b squared minus 4ac over 2a. The denominator is negative 1.4. Put this into your calculator. 3 squared minus 4 times negative 0.7 times negative 7.5. And you will get negative 12 here. Case 3, the case of no real roots. So we will not continue here if we get a negative under the square root sign. Okay, so we won't bother to use our J operator and find the complex roots. We'll simply state no real roots. Okay, one final example, number 4. Again, the first step is to make all terms go to one side of the equation and in the correct order. So I brought everything to the left, so you can see I have positive 2x squared plus 3x minus 2 is 0. That would mean my values are 2, 3, and negative 2 for A, B, and C. If you chose to bring your terms to the other side of the equation instead, you would have all 3 signs here different. So negative 2, negative 3, positive 2. And those could also be used to give you the exact same 2 answers. Okay, so here we go. Substitution into the quadratic formula. The denominator is 2 times 2 or 4. In this case, the discriminant is positive 25. We should have 2 answers now because of that positive number here. 25 is a perfect square, so we can simplify to the integer 5 here. And therefore, our 2 values will have in their numerators negative 3 plus 5, negative 3 minus 5. This numerator will be 2, so we have 2 quarters or a half. This numerator is negative 8. Negative 8 quarters is equal to negative 2. Okay, so thanks for watching that. And now you know 3 different ways to solve quadratics. One method is by factoring. The second, using completion of the square. And today's lesson provided the third method, which was using the quadratic formula.